Good morning, students. In my last videos, I explained you electromotive force and resistance. Today I will explain you internal resistance of the cell. Say, if it is a cell, A and B are the two electrodes kept in the electrolyte. When cell is not in use, then the potential difference between the two ends, that is the electromotive force. Now, if we put a resistance in the circuit, or we put a appliance in the circuit, current will flow from positive to the appliance, then go back by the negative end. Now here it is an open or it is a circuit of A, R and the B. Between the two terminals, resistance R is there. This is known as the outer circuit or the resistance in the outer circuit. Now what happened inside the cell? Inside the cell, current flows from negative to the positive through a electrolyte. Now here, one thing is very important, that in the outer circuit current flows, that is the electron flows from positive end to the negative end. But in the case of the cells, that is electrolyte, current flows by the movement of the ions. Electrolyte dissociates to form the ions. So in the case of the cell, current flows in the electrolyte by the movement of the ions. Now, this flow of the ions, that is inside the cell, resistance offered by the electrolyte to flow the current. So resistance offered by the electrolyte, listen, this is electrolyte inside the cell. Resistance offered by the electrolytes inside the cell to flow the current is called the internal resistance of the cell. So the point is that one resistance outside the circuit, that is the flow of the electron, but inside the cell, electrolyte is there and electrolyte dissociate to form the ions. So flow of the current in the electrolyte is obstructed by the ions. So this resistance by the ions in the electrolyte inside the cell is known as the internal resistance of the cell. And in my last video I explained the voltage drop of the cell. This voltage drop is equal to current into resistance small r. This small r is the internal resistance. Now if we take the complete circuit, that is outside and the inside, the total resistance is capital R plus small r. And we know that the current is equal to EMF upon the total resistance. So current is equal to EMF upon R plus R. Or we say that the EMF is equal to current bracket R plus R. Now we know that the EMF, that is the electromotive force, is equal to terminal voltage capital V and the voltage drop small v. So here voltage drop small v is equal to potential, that is EMF minus terminal voltage. So R is equal to drop in the voltage upon the current, and this drop in the voltage, that is small v, is equal to EMF minus terminal voltage. So this internal resistance is equal to, that is EMF minus terminal voltage upon the current. Now we know V is equal to IR, then I is equal to V upon R. So putting the value of I here in this equation, we get EMF minus terminal voltage upon V upon R. So is equal to the EMF minus terminal voltage upon V in R. R internal resistance is equal to EMF upon V minus 1 into capital R. So this is the internal resistance. Now as the some factor of the resistance, in the same way some factors for the internal resistance. Now we know that the resistance is inversely proportional to the area. So here we will take the area of the electrodes. So R is inversely proportional to the A. More the area of the electrode, less the resistance. And you know resistance is directly proportional to the length. Here length will be the distance between the two electrodes. So distance between the two electrodes, more the distance, more the resistance. But in the case of the temperature, more the temperature, less the resistance. And R is depend upon the concentration of the electrolyte. That is the non-ionic or the more concentration or the higher concentration of the electrolyte, and then more will be the resistance. So this is all about the internal resistance. So internal resistance is nothing but the obstructions of the ions in the electrolyte to flow the current inside the cell. This is known as the internal resistance of the cell. Okay, I think it is very clear to you what is about the internal resistance. So if you like my videos, please share and subscribe. Thanks very much.